Good morning, everyone. Welcome to the Congress Hall A of the Data Science Europe 23. My name is Ivana Milenkovic, and I will be your host. I would like to welcome you on behalf of the organizing team of Data Science Conference Europe 23. We are happy that you're joining us at the biggest AI event in Europe. Okay, our first speaker for today is Antoni Ivanov, a staff engineer at VMware and the brains behind Versatile Data Kit, will enlighten us on the evolving landscape of data workflows. His presentation will delve into the paradigm shift from traditional task-oriented approaches to a more data-centric model. Instead of fixating job orchestration, the focus is now directed towards fostering high-quality, accessible, and well-documented data sets. Antoni will showcase how this shift places data engineering in the forefront, elevating the creation of data models and assets as primary objectives. Through demonstrations featuring cutting-edge tools like Mage.ai, Airbyte, and Dagster, he'll spotlight the significance of the data-centric approach in reshaping our understanding and utilization of data. The title of Antoni's talk is Make Data Central Feature. Thank you very much. Please join us.
Hello, and thank you for having me. As mentioned, today I'll be talking about Make Data Central Feature. I want to discuss, as data practitioners, be it ML engineers, data scientists, any kind of, we use tools, frameworks, libraries, SDKs, any kind of tools, I'm going to call them, to make our work more efficient. Well, the goal, of course, is to minimize the time we have to do amount of work, so we can do more work, so we can provide more value for our customers. And as we use those tools, I am going to make a statement that the last 5 years, tools that are really successful at minimizing our time are those that really make data central feature. I'm going to talk about what does it mean to be data-centric tool, and what the previous tools, task-oriented tools, are in comparison. How many of you would think of themselves as data practitioners, like data engineers, ML engineers, data analysts, people who manipulate and in any way data? Cool. And are there some of you who actually built such kind of tools, framework, SDKs, and on the other side, providing tools for other data practitioners to use? So, cool. So I hope this talk is useful for both. As data practitioners, I hope you start thinking about the next time you're evaluating a tool or framework, is this data tool really data-centric? Does it make data-central feature? And if you are building a tool, maybe the next time you're thinking about new capabilities, you're going to think about how to make those capabilities more central feature, more data-central feature, data-aware features. Cool. So very quickly, I want to go over the data engineering cycle. So if we are working on any kind of data project, of course, after we make sure to understand the business requirements of the project, first thing we need to do is discover what data we need, right? After we discover what data we need, which is not easy tasks, then we need to get this data somewhere, collect it, fetch it. We're going to call it integrated because it could come data from multiple sources, and maybe we want to integrate it into a data lake or even in our local notebook environment. And then we do some kind of transformations. This could be dimensional modeling, where we create 5D tables. It could be training ML model or AI model. And of course, we need to deploy this data. It might be in the form of a report, BI report, or it might be in the form of API, like module for inference. And all this needs to be managed over time, which means operated, monitored. You need to follow quality metric for both the data and the applications. This is very quick, like a reminder to say the same. I hope we're on the same page here. So in order to talk about data-oriented tools, I first going to start with more about the previous tools that were really making their mark, and I'm going to call them task-centric tools. Those task-centric tools provide task-centric interfaces. In task-centric interfaces or tools, the data practitioners, they need to write this kind of logic. It might be a code, or it might be UI-driven, in which they either ingest, integrate, or transform the data. But also they need to think about how to create each different task or job, what the task needs to contain, what is the logic of the task, and how each task needs to orchestrate between each other. So which task follows which one, which task need to run in parallel. This is something that with task-centric tools, you need to figure it out by yourself as data practitioner, and this is quite a bit of time that you need to take. Usually those kind of task-oriented tools tend to provide something I'm going to call orchestration API. Those orchestration API will provide interfaces or abstractions, the things that the data practitioners use, that we use, like task, data job, workflow, DAC. And very classical example is Airflow. Airflow is really this kind of task-oriented tool that became popular 10, 15 years ago and really helped a lot in data engineering by providing a way to orchestrate, think about your data workflow as multiple set of tasks and orchestrate those tasks in a direct acyclic graph, they call it DAC. And you'll be able to schedule and execute them, and then you also can manage them by troubleshooting certain tasks, restarting certain tasks, having them see in a UI, monitor them. While this was certainly extremely helpful, you still need to remember each task which exactly data is managing. So you need to have this kind of mental link between the data sets that you care about and the task that you have created or somebody else has created. You need to design those tasks in the correct way. You need to make sure that the tasks that run in parallel, parallelized, and tasks that depend on each other are the dependencies are specified. So one task starts only if another task has met certain condition. And in the past 5 years, perhaps, I think we see a trend which aims to improve upon this. So from task-centric interfaces, now we're switching toward more data-centric interfaces. So now we're going to talk about the data-centric interfaces, the new way of tools are being built. In data-centric interfaces, as we can see, this kind of work that we had to do about orchestration, thinking about the task, thinking about how this task needs to be orchestrated one after another, how it needs to be parallelized and so on, is disappearing. So this is not something that we worry about. And instead of using orchestration API, now we're using a data API. A data API would has things like model, source, destination, data set, asset as its an abstractions, the thing that we as data practitioners would use. Those kind of things tend to abstract or simplify the way we manipulate data. So now we use much more declarative approach to specify what kind of data sets we need by specifying the transformation as a declarative way. As an example is 1,000 words. I'm going to show you 3 examples in the sessions. The first one would be DBT. The second one will be the tool I work on, Versatile Data Kit. And the third one is Dagster. I'm starting, let's quickly show DBT. DBT is probably the first tools that really started thinking about how to be data aware, data-oriented interfaces. So, for example, we're going to talk about what are the abstractions, the interfaces that DBT provides that make it much easier to manipulate data. DBT, if you don't know, is a tool which primarily focuses on SQL transformation. So allow you to specify any kind of SQL transformation so that you can create models in a database. So one abstraction that DBT started to provide is sources. So you can populate basically the table or the view that you have in the database behind this kind of source. And the other big abstraction that it provides is model. So now you think about what is the model that you want to create. So for example, maybe you want to create a dimension table product sales, and this is your model, and you specify, I have a model called product sales, and this is the transformation that is necessary in order to create this kind of model. In this very simple example, select product name from store sales. And when we specify this transformation, DBT knows you can configure with DBT to decide whether this model will be materialized as a view or as a table. And DBT would know to make sure that all the dependency of the model, which is the from something in the query, are updated before this model is being updated. You don't have to worry about this. You don't have to think about what are the tasks that needs to be created behind the scenes. DBT does this within a single process using multiple threads to parallelize them. Before we continue with my other two example, I've created continuum diagram of open source projects. In this continuum diagram, you can see the task-oriented tools or projects that we use, things like Airflow, Luigi, and Argo, which provide you more task interfaces. And the latest two things like Great Expectation, Airbyte, DBT, Mage.ai are much more data-centric tools, where you think a lot more in the abstractions of data sets. I'm going to focus particularly Dagster and Versatile Data Kit. Versatile Data Kit is the project I work, which started more as task-oriented tools and is moving toward being model-centric. Dagster is another good example for such a tool that started more text-oriented and moved toward being data-centric. Interesting tidbit, while I was creating this continuum diagram, I consulted with colleagues, but also asked ChatGPT to its opinion, and it created very similar diagram, except putting Dagster much on the left. Part of the reason for putting Dagster much on the left, since I'll talk a little bit, is because Dagster started really task-oriented too, but in the last 2 years, he's really moved toward being data set oriented. So I'm going to use very simple scenario for my other two examples. I'm going to do an ETL scenario, go to the engineering cycle, and analyze review efficiency. So we'll try to ask a question like how long it takes for some review to be completed, and which are the components that takes most comments, for example. So the first step, of course, is to discover the data. So I am going to use GitHub data from the GitHub API. We care about things like pull requests, users, and comments that we want to fetch from this GitHub API. The second step is of the data engineering cycle, so you need to integrate and ingest the data. So we're going to use Versatile Data Kit for this. And here I'm going to focus mainly on the interfaces that Versatile Data Kit provides. And hopefully we'll make it clear how they're much more data-oriented. So let's see, very quick demo. So this is a Jupyter Notebook. Versatile Data Kit has the Jupyter Notebook integration, where you can specify your ingestion logic or transformation logic in the notebook cells. You do it by specifying this kind of VDK ingest. And the first things you want to specify is, of course, the sources. If we're going to do ingestion, means we need to copy data from one location to another. We need to specify the source. In our case, the source is GitHub and some GitHub configuration. Versatile Data has a list of sources that you can see. So SingleTap is one of those, which is a single project, open source project with multiple sources, and we're going to use the tab GitHub. So this is the first abstraction. We specify source. Then we need to specify a destination. So we're going to use some very simple destination SQLite, but you can specify both multiple sources and multiple destinations. Now, once we have the definition of a source and destination, what we need to define the flow from which source to which destination the data goes, which happens with, again, more declarative approach by simply specifying a list of flows. In our case, we specify just one, which goes from GitHub VDK repo. This is the ID of the source that that's the ID used. And then we're going to go to destination called SQLite, which is the ID of the source, the destination that we specified. So now you can execute this, and Versatile Data Kit would know automatically how to connect to the data source. It would parallelize in multiple streams the flow of data from the source to the destination. If you have multiple sources, multiple destinations, make sure that all the tasks necessary for those sources and destination flows to work in parallel would be done automatically. So basically, behind the scenes, it orchestrates everything. But we just need to worry to declaratively specify the correct configuration for source destination and the flow. So this is the kind of data-centric interface that hopefully new tools should provide. You can try this at home. There's this tutorial which basically would walk you through what I did, except for more than 30 seconds, probably 10-15 minutes, and you'll be able to see how Versatile DataKit data-centric ingestion flow works and understand it better. If you take a screenshot, wait a few seconds. The next example, well, we're going to step 3, transforming the data. So in order to be able to answer our questions, how long does it take for pull request to merge, how many comments it takes to be merged, we were going to be doing dimensional modeling. So we create our factor dimension tables using Dagster as a for transformation tool. So let's say that we want dimensions about date and component, the project component that we care about, and we want fact table which will track each time a PR is merged. So I'm going to name it fact PR merged. So we use Dagster. In Dagster, what are the interfaces? So we're now talking about a new tool called Dagster. Dagster, one of the interesting things about Dagster is it started almost as an improvement or replacement for Airflow. So it was really task-oriented. It had this kind of concept of operations. But in the last 2-3 years, they really focused on creating this kind of new interface they call software-defined assets. This is on top of the orchestration API, which they call operations. They now allow data engineers, data practitioners to think about the code and the transformation logic that they create in terms of assets and how those assets cooperate and operate and materialize. So let's see an example. So here we are going to, the GitHub data that we ingested in the previous step, we are going to transform it into dimension and fact tables into a Snowflake database. So we've defined here our Snowflake database configuration. And as the next steps, we are going to define our logic. So here we are defining 3 assets, or 4 if you include the GitHub source asset. We're going to define a dimension component, dimension date, and dimension fact, and the fact PR merged asset. Should be similar to what we saw with DBT. The fact PR merge asset is defined as a transformation, which uses all 3 previous assets as part of its transformations. It uses the GitHub raw data in order to get the details about fact PR, and depend also dimension data and dimension component assets in order to be able to create the join keys correctly. The transformation logic doesn't matter, but the important is that now that we've defined this kind of 3 assets, when we're creating our logic, when we're creating our transformation logic, we were thinking just about what are the assets that we need to create. And we just define them, and then define what is the transformation logic that's necessary in order for them to be created. And from then on, Dagster takes over, and it will basically able to correctly infer the orchestration, so as this. And once we execute it, which they call materialization, so once we materialize this kind of assets, it knows that first it needs to materialize the assets for date and component, because they're needed later in order to materialize or update the asset about fact PR merged. And this is something that Dagster is able to infer automatically based on the logic of the transformation logic in the assets that we specified in our code. So, as a summary, hopefully you see the benefits of having data-centric tools. The goal is to simplify a lot and reduce the amount of time we need to do things, because now we don't think about tasks. We don't need to keep this kind of link between task and data set, because the tool would keep it for us. We don't think to keep about how to orchestrate those tasks, because the tool does it for us. We just think about declarative way of defining our assets, sources, or destinations. In this example, I showed you two demos. One was using Versatile Data Kit, and we discovered how it uses abstraction like sources, destinations, and flows to describe the ingestion or integration process. And we export quickly Dagster, which uses abstractions or interfaces like data assets and data materialization to specify what is the transformation output that we want to achieve. Well, that was everything from me. I hope you have questions. You can contact me on LinkedIn. And if you have any time to complete the survey, I'll be really grateful. That will be really helpful to understand more about your problems and whether this is something interesting topic for you, or if you want to put in contact, of course, I'll be happy to talk to anyone. Thank you.
Do we have questions now or questions now? Anyone? Okay, please, yes.
Yeah, I'm just introduced to this transformation step just recently, so I don't know much about it, but when you talk about transformations, what do you think, what do you actually mean? Are you thinking about merging tables? Are you thinking about, I don't know, any kind of operations, or what is the scope there actually when you're talking about transformations?
In the transformation step, we separate the ingestion transformation step as a best practice EOT approach, because we want to make sure that the source data, we ingest it, copy it with very little changes, so that we can use it for multiple use cases, and we reduce the chance that we introduce a bug if we do transformation in place. So let's say that we copy it into data lake, then we can do multiple types of transformations. One popular one is called dimensional modeling, where you are able to think about the business processes that you want to model. Like in this example, I want to model dimension component and PR merged, and able to fetch the data. Usually, in order to be able to define the correct business process or dimension, you need data from multiple different sources. From multiple sources, you need to join it between these sources in order to create the correct dimension with the correct columns that you need that clearly described this kind of, for example, component. And something like this you need to be able to do. And sometimes you may need to do this multiple times where you rely on previous dimensions. Another type of transformation that's, of course, talked about a lot is simply training a model. In this case, you get this raw data and you need to be able to train it, create embeddings, or depending on the types of training, can create your model, which then deploy, which can be used for inference later. This is also a type of transformation.
Thank you.
Do we have another question? Yes?
Just as a curiosity, you have the line between the task-centric and the data-centric. Does it have any other criteria for the top ones and the bottom ones, or are you just organize them?
No, just left to right.
Okay. Thought maybe there was some prior there. Okay.
Anyone else, please? Is that all? Okay. Thank you. Thank you very much.
Thank you.
This is for you. We would like to express our sincere gratitude for your contribution to Data Science Conference 23. Thank you very much.